Okay, classes of Precalculus. Most of you are in dual of STC, so throw out a reminder to STC students that the deadline to drop is April 20th. So make contact with your counselor Gonzalez and myself, and let us see what we can look at. Also, as I mentioned in a remind message, that I'm putting grades into the Blackboard of STC. I've already set everything up, and I'll be popping things in there so you can get a visual of where you stand for the pre-calculus class. Okay? That way you can make an informed decision before April 20th, which is right around the corner. Okay. Okay, chapter 8, we're still there. And the application of trigonometry that we're using today is Law of Cosines. Law of Cosines piggybacks off of what we had the last lesson was Law of Sines. And Law of Sines was used to solve triangles. Well, Law of Cosines is also used to solve triangles. And when I say solve triangles, it means to see. See you guys later. To find any missing angles and missing sides. And we dealt with a whole lot of examples that Law of Sines works real well. If you recall, Law of Sines always had to have an angle with a side pair. You had to have one of those every single time. Because if you were looking for, obviously you're going to have another side or another angle being used, and it really doesn't matter. I could have had B, I could have had C angle, I could have had side B, I could have had side B, but I need to have three things, and two of them had to be a matching pair. Law of cosines, though, allows you to only have an angle and two sides, like that. You couldn't do that before, okay? Because you had too many things. Let's see. I had to give a thought for that. I'm pretty sure that's the case. In any triangle, the sum of the lengths of any two sides must be greater than the length of the remaining side. Well, where did we have that at? We had that in geometry class. That if you add up any two sides of a triangle, that sum, A and B, A plus B had to be greater than the third side, C. Has to be. If not, the triangle cannot exist. And that was one of the things we did in geometry class. So what the author does, he uses that idea to derive the law of cosines. And I'm going to go through this rather quickly because most derivations, we kind of, our eyes roll back to the back of our head. We watch it, and your teacher's never going to make you do it. But for those that are geeks, let's look at this. Let A, B, and C be any oblique triangle. Remember what oblique meant? It's not a right triangle, okay? And so it's oblique. And it's located in the coordinate system. So what this author did, he put the origin as B. Then he had a point out here in quadrant 2 and a point also on letter C, also on the x-axis. So he labeled these points. Now, this side of this triangle is A, so it makes sense that distance is A, and the height was 0, so AC is A0 is C. And for the point in quadrant 2, it's an x distance because it doesn't correspond to any other side of the triangle. So it's just an x distance. Likewise, how high it goes is just a y value. So technically, we could call that a negative x comma y. Maybe we'll refer to that in a few minutes. And he has some other things labeled here, but we'll talk about those in a minute. The point B is at 0, 0, the origin. The coordinates of A, he's calling it x, y. He's ignoring the negative because it doesn't really matter. X could be negative. So if I don't put the negative there and realize x could be positive or negative, that's why he didn't use the negative xy, because it'll work easier if you just say x could be anything. And for angle B, he calls, look at angle B. He's calling angle B this angle right here. And we are looking at this right triangle that got created with this x, y, and angle B. So angle B is this angle here. And using the law of, not law of sines, using the identity of sine, the sine of angle B would be opposite over adjacent. Opposite has to be the y. And this C is side C of this triangle, the big triangle, that the oblique triangle that I care about, ABC. So that's side C. That makes sense. But if you solve this for y, then you get y is C sine of B. Now we do the same thing for cosine of B, but now I'm over here. So cosine of B is adjacent over the hypotenuse. So we got x over c. Solve that for x, we got x equals c cosine b. So remember when I wrote that this point was x comma y? We'll substitute in what y really is, cosine of b right here. C sine of b. And the cosine of b equals x over c, giving x is cosine of b. Well, there you've got your cosine of b, your c cosine of b up here. That was my x comma y. Knowing that, we've come up with a new coordinate for point A. We're going to use that. So we're going to continue with this. If this is my ordered pair, and let's see, this would be the x value. I'm sorry, the y value. This would be the x value. And this is C, of course, is the hypotenuse. But that hypotenuse is the one I care about. I care about this hypotenuse. Do a different color. It's not even a hypotenuse. It just may very well be the longest side of my oblique triangle. So if we use Pythagorean theorem on the larger triangle, it's in this picture, we technically have y squared plus all of this, but y is now called c sine of b. This is my y and this is my x. So, and my x value is, the x value is this part right here, c cosine of b. This whole side is the combination of this distance here, this x value here, plus a. So you can see what I have written here. What he doesn't have is b squared, which would have been my long side of the oblique triangle, is equal to this side squared, which is the c cosine of b, minus a. That should remind you of one of the x's minus the other x. squared plus 1 of the y's minus the other y squared and take the square root. That's from the Pythagorean theorem, giving you that distance formula. I should do it this way. Distance equals the square root of one of your x's minus the other x squared plus one of your y's minus the other y squared. That's your distance formula. So that's what he's doing. So this distance b, this side b, is cosine of b minus the a, the x is squared, plus the cosine of the c sine, I keep losing the c cosine b minus a squared, plus c sine of b minus the 0, because there's a 0 right there, squared. Now, go ahead and square both sides to get rid of the radical. And we have all this gobbledygook, okay? And it's hard to believe anything can come out of it. But if you look carefully, there's two terms that have the c squared. So we will factor that out. Now the a squared is minding itself, its own business, and so is the minus 2ac cosine b. Okay? And you're wondering, where did those come from? Somebody was nice enough for you to take c cosine of b minus a multiplied by c cosine of b minus a. And also, well, this is easy. When you do c sine of b minus 0 squared, that's just c sine of b squared. And so that wasn't too hard, and that's c sine of b all squared is right here. Now this other stuff came from c times c is c squared, cosine of b times cosine of b is cosine of b. So you got c squared cosine squared b. Then you've got c cosine of b times the a with a negative. Then a c cosine of b times an a with a negative. That's where you get minus 2a c cosine of b. Then you have a minus a times a minus a. That gives you your plus a squared. So that's where that came from, right here. These two give you that, and then this gives you that term. So anyway, I'm sure you saw where he didn't show you that step. Factor out the c squared. Now you have inside this parenthesis sine squared b plus cosine squared b. Does that sound familiar to you? You should all be yelling out, that means 1. Sine squared plus cosine squared is a 1. So what are we going to do with that? A squared plus c squared, that c squared is times a 1. It goes away, minus the 2ac cosine of b. So what you have looking at you now, b squared is equal to a squared minus c squared minus 2ac cosine of b is the law of cosines. Oh, I know you're so excited. What does that mean? Well, it means we have 3 of them. Because if you have a triangle and A, B, and C, and this is small, let me do my small b, small c, small a, those are my sides, that whichever side you want to solve for, let's just say like right now, do the first one here. I'm looking for a. Well, a squared is equal to the other 2 sides squared, added together. Boy, does that look familiar. Doesn't that look like Pythagorean theorem? A squared plus b squared equals c squared. Matter of fact, look at that's right here. It's the same piece. Well, what if I'm looking for c? Then I can say c squared must be b squared plus a squared. There it is. C squared must be a squared plus b squared. But every one of these has this weird combination at the end. Look at it. If I'm using a b and a c here, then I'm also going minus 2bc cosine a. If I'm using an AC, then it's minus 2AC cosine B. If I'm using AB, then it's minus 2AB cosine C. And the angle is always the one that matches the side out here. So if you're looking for A, you need to have angle A. They go together. B will have angle B with it. Now, you may not realize this, but Pythagorean theorem actually works in this problem. Because if angle C is a 90-degree angle, and I'll call these A and B, so that means this is side A and this is side B, let's see if it works. If I'm looking for C, and it's across from the 90, C squared will have to be equal to the A squared plus the B squared, just like in Pythagorean theorem, but we're going to add one more little thing. Minus 2AB, because that's what I have here, cosine of what angle? The angle that goes with side C, C. Now, C is a 90-degree angle. So what is the cosine of a 90-degree angle? So think about it for a minute. C squared equals A squared plus B squared minus 2AB cosine of 90 degrees. Have you figured out what it is? It's a 0. So this goes away. Well, man, that sure looks familiar. C squared equals A squared plus B squared. Maybe this is where that formula came from. No, I think the formula came first. But it works. No matter what the angles are, it'll always work. Ready to use it? This is what I just showed you. Okay, example 1. A surveyor wishes to find the distance between two inaccessible points A and B on opposite sides of a lake. So my picture would have this lake, and I would have a point A over here, and I'd have point B over here, and they're on opposite sides. And while standing at point C, she finds out that, let's see, I'm making it up. I'll put C right here. She's standing at point C, and when she stands at point C, she finds that B, the distance that would have been this distance right here, across from B, angle B, is 259 meters, sorry. And she knows that A, side A, and probably the lake didn't look like that. I mean, that she could technically, if she could walk that far around the lake and put a measuring tape, she could probably walk around the lake, but you get the point here. Side A, which would have been opposite of angle A, so that would have been this side here would be A. She measures herself to that point, and she finds that was 423 meters. And the angle, she uses a protractor so she can measure the angle between those, or a surveyor tool. And she finds out that angle, which is angle ACB, is 130 degrees and 40 minutes. Angle C, 132 degrees and 40 minutes. Find the distance C. All right, so there's the picture. And so what I'm looking for is this side over here. So even if I'm going to go to the next slide and you will see a better picture. We have C across from the angle that I know, and I have the two sides. I basically have that angle sandwich that I talked about the other day, the angle sandwich. So C squared is going to be equal to one of the sides, A squared plus B squared minus 2AB cosine of angle C, which has to match C. That's how we'll find out. We can easily find this by plugging everything in. There's a better picture. This sort of makes more sense at why she could not find the distance between A and B, because the lake is very, very long. And it was bad enough that somebody walked over here and we measured that distance, which wasn't bad. And then another person walks to B and measures that distance. The same idea. It's the same picture. So I'm going to plug in my numbers because I'm going to write it out first again. It was C squared equals 2A squared plus B squared minus 2AC cosine of C. C squared is what I don't know. And A was equal to 423. So it's 423 squared. And B was equal to 259 squared plus 2 times 423 times, what I write here, 2A, should be AB. B was 259. 259 times cosine of my angle, which was, I'm going to cheat because I remember from the other lesson that 40 minutes was the same as 0.66666. So I'm going to write cosine of 132 point, and I'm going to use a lot of sixes, 6666 degrees. That way it all makes sense. Okay? Now, when you get done plugging all those numbers in your calculator, we're going to take C and we're going to square root of that answer. So I'm going to go and use my calculator, use your calculator, and I'll come back to you. So you should pause the video now. $394,510.6. The reason I stopped at one decimal was because if you look at his problem, he didn't have any decimals, and the 40 minutes would be a 0.666. So I just, I could have taken another sixes, I guess, in there. All right, now, got to take the square root of it. So C will be approximately. All right, so let's get ready for the answer. I'm going to go to the calculator. I'm going to hit square root of my answer. $628. If I have no decimal, since he didn't have decimal in the other measurements, meters. Look at my calculator again. Yeah, it's fine. All right. Oh, I had a whole more room here. Oh, there's all the work. Perfect. Good. He said approximately, about. Of course, we rounded twice. All right. There's our magic word, solve. Solve the triangle. That means I already know what A is because it's written there, 42.3 degrees. I don't know angle B, and I don't know angle C. I don't know side A, but I know B is 12.9 meters, and C is 15.4 meters. So I have to, the law of sines won't work for this problem. When you have the angle sandwich, It's a good candidate for law of cosines. All right, so I'm looking for side A. It goes with angle A. So obviously I'm going to start with looking for A. A squared must be equal to the other two sides, B squared plus C squared minus 2BC cosine of the angle that's goes with the A. A. Plug everything in. A squared equals to 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 cosine of 42.3 degrees. And again, this is all plug and chug. Go to your calculator, type in that, plus minus number times number times number times cosine of this angle. Hit enter. When you get done with that, take the square root. Okay, so when I come back, I will have the answer for A. Why do I want to do it? Let's just move on. I'm sure the author, well, no, but then the author didn't solve the others. I'm sure that's the first thing he solved for. Let's go look. 10.47. I have all my sides, but now I got to find angle B and angle C. I'm going to put it over here then. 10.47 meters. So if I got to find those two other angles, what you could do is you now could do law of sines. Or you could do law of cosines again. You know, you actually, I kind of like the idea of doing a law of cosines again. But law of sines will work. Maybe it's a good idea to do law of sines to remind you of the last lesson. So let's use A, because we have a match that goes with A. So we're going to need that. Let's look for angle B now. So here goes. Law of sines was sine of, I'm looking for angle B, sine of B over B equal to sine of A, I already have, over A that I found. So sine of B will be, I don't know yet, sine of B over B, which I do know is 12.9, has to be equal to sine of A, which is sine of 42.3, over the answer that I had just found of small a, which was approximately 10.47. Now you know that I already rounded to get to 10.47. So there's already one rounding mistake in there. But the angle he has in the problem only went to 1 decimal place. So I'm probably okay at 1 decimal place. So sine of B, sine of B will be equal to sine of 42.3 degrees times, this is going to go up that way, 12.9, all divided by 10.47. So sine of B will be some value. Let's find out what that is. Go to your calculator, key that in, give me that number first. 0.8292. Now, I'm going to do the math looks like this. Next time I'm not going to do it. I'm not going to show you the step. I'm going to get rid of sine by arc sining both sides. Arc sining both sides. That'll give me what B is. Okay, so we come back. 56.01 degrees. And since he rounded to 1, I'm going to put approximate. It's all approximate anyway. 56.0 degrees. 56.0 degrees. Now I know what you're thinking. I could do law of sines again. Or I could do law of cosines. Yes, you can, but why would you want to when you already have the triangle angle theorem that says that the three angles have to add up to 180? So the measure of angle C will be 180 degrees minus my 42.3 minus my 56.0. So that's 180 minus that sum. I should go get my calculator, but I'll try to do it. 50, 60, 70, 80, 90, 96, 97, 98, 98.3. So approximately, let's see, that's 0.3. Let me pretend it's 99, and then I'll add 0.7. If I take 99 away from 180, that'd be a 71, and add the 0.7, 71.7? I hope. We'll look at the other side. 77.7, 7, 8, 9, 10. Carry the ones. That's 14, 15, 16. Oh no, I don't think it's gonna work. I don't think it's right. Uh, no, that's not the right sum. So I'm gonna have to go and do my calculator. Let me look. Or 50, 60, 70, 80, 90, 96, 97, 98.3. Oh, I was going to add, pretend it's 99. That would be 81.7. Whoops, what? Don't know why it's going to write text for me. I don't want you to do text. There. What did I say? 180 minus 99. 81.7. That's what I was going to type in. 81.7. Let me see if that works. 6, 7, 8, 9, 10, 5, 10. Yeah, I think so. 81.7. See how much fun it is to... So let's go. Let's check our answer. Yes. That's the first thing you solve for. 10.4 meters approximately. Now, I'm going to put that over here. 10.4. 47. Sorry, 10.47. So I'm still left. Let me put that back on their side. Well, we already checked that answer. We checked the other answer. Angle B, 56. 80. Ha, I should have just looked over here. Okay. Way to go, guys. Thanks for your help. Go back to my problem. The sine of A over A was, I have to use that pair. But why would I go after the B? The side is smaller than this side. So it would be better to go with a pair that will be also the smaller angle. If you always go for the smallest angle, you'll never have any to worry about, oh no, I need the supplement. That's my advice to you. Always solve for the smallest angle first if you can. How do you know what's the smallest angle? It's across from the smallest side. Just a little cover page. Now, he said, have we used the law of sines to find C rather than B in example 2, we would not have known whether C was equal to 81.7 or its supplement. I got some advice to you. Always shoot for the smallest angles. So if I did a tidbit of trivia treasure that I had. Let's do another one here. And I may not finish anymore because this is the gist. Applying the law of cosines. And this time he's giving me side, side, side. I can't remember. He gave me side angle side on the last one. Side, side, side was another one that you could not use law of sines for. Could you? Let's see. Yeah, you could have. Yeah, you could have. So here's A, B, and C. A is 9.47. B is 15.9. And no, you couldn't have. I changed my mind. It's 21.1. Why I'm thinking is you have to have, you'll have two sides that you could use, but you want to have two angles. You always got to have an angle in order to do law of sines. So here's another one that you could have done with law of sines, because no matter which angle, you go sine of A over A equals sine of B over B, or sine of C over C. Either pair needs two angles and a side, or two sides and an angle. So you have to have an angle. I don't have any angles. So I'm angleless. Okay. So I'm going to pick, and I told you, go for the smallest ones first. So the smallest side is the 9.47. So I'm going to shoot for these two combinations in my law of cosines. I'm just saying. So let's get to work here. Ooh, wait. I'm not. That's going to be interesting. Let's try it. A squared. I don't want that color. A squared equals to B squared plus C squared minus 2BC cosine of A. A is 9.47. 9.47 squared equals to B squared 15.9 squared plus C squared is 21.1 minus 2 times 15.9 times 21.1 cosine of an angle that I don't know, A. So what's going to happen? You're going to work this out. You're going to work this out. You're going to work this out. Then you're going to remember there's a minus here. You're going to go multiply these three numbers, the 2, the B, and the C. Okay? Then you're going to solve it for the cosine of A. So when you get done, you're going to look at this. You're going to say cosine of A will be 9.47 squared minus 15.9 squared minus 21.1 squared divided by negative 2 times BC 15.9 15.9 and times 21.1. Then you're going to do the arc cosine of that answer, and that's going to give me my answer. Okay? So, this is a job for you. Type it in. I'm going to do it. I got 24.954 degrees. No, that doesn't go there, sorry. It goes. I can't remember what my decimal was. Let me go back and look what my decimal was here. Oh, what was I doing? I was doing the arc cosine of the answer. Let me go look. It was 0.9066. And that gave me a 24.954. which the angle he's got one decimal. No, he got two decimals here. One decimal. Doesn't say. I'm going to say approximately, let me round it up to 25 degrees. Okay. So now I've got one of the angles. I got angle A. So I did this one. I'll do another angle. I'll use law of sines. Now, as I look at this problem, I got to find C or B. So B is across from 15.9. So that's the one I'm going to try to find first. I'm going to do sine of B over B. I'm going to pick the pair that I just have, sine of A over A. So sine of B, I don't know, over 15.9 equals to sine of, I'm going to use the 25 degrees I said, over the 9.47. Wait, what did I say? I said look for the smallest one. Am I looking for the smallest one? Is B smaller? Yeah, okay. So sine of B will be equal to 15.9 times sine of 25 degrees over 9.47. Okay, so I want to know what angle B is. So whatever answer you get, don't forget to second sign that answer. I'm going to work on it. I got 49.1999 degrees. And that is not big enough to make that to a 50. So I'll just call it approximately 49 degrees. So now I've got, this was 25, approximately. This is approximately 49. So I just looked at my calculator. It's 45. I don't know where I got 49. 45.199. 45. Okay. So let me go back over here. 45. So how I get my third one? Well, 180 minus 45 minus 25 is approximately 180 minus 70 then. No, 40, yeah, minus 70. So I'm going to go with 110. Let's see how close we are. 25, oh no, 110 was this one. 45, 25, 45, 110. Let's look. Yep, 110. That'll round to 110. I rounded them to whole number. I don't know. I just did. Then 45. That rounds to 45. That rounds to 5. So, yeah, I'm fine. Just rounding differences. Okay, example 4. Designing a roof truss. A roof truss. I don't know. I have no idea what a roof truss is. I just see a picture of a triangle. I don't know what truss even means. Whoever messages me what the answer is, what a roof truss is, I'll give you 5 points on your last test. Okay, it's going to have to be the first person. So whoever watches this video first will get it. Okay, we're looking for just one angle B. Angle B. So that matches up with here. So that works out good. And I have my formula already. B squared is equal to A squared plus, okay, so let's plug everything in. 6 squared equals to 11 squared plus 9 squared minus 2 times 11 times 9. Cosine of an angle that I don't know. This time the numbers are easy to use, so I won't I won't move it all on one side. 36 equals to 121 plus 81 minus 2 times 99. I don't know. 18, 19, 198 cosine of b. Either way, I got to take 36, bring the 121 over, bring the 81 over, and divide by this part that's next to cosine of b. Divide by negative 198 will equal to the cosine of b. Okay, so let's go to the calculator. Let's plug that in. 36 minus 121 minus 81. 0.83838 equals cosine of b. Second cosine, I get b is equal to rounding to a 33 degrees. Okay, so could be if I only knew what a roof truss was. 33. Read your chart. You're just gonna fast forward my talking these things over anyway. Last thing, Heron's formula. It's another area formula. Remember the other day we could only do the area when we had an angle and then we had two sides that made the angle sandwich? That's fine. But wouldn't it be cool if we had any triangle that I knew the sides and I didn't even know any angles? This is cool because with Heron's formula, this is a number sense trick, is you have to find the perimeter of this triangle, a plus b plus c, and take half of it. That's called the semi-perimeter. Semi means half. So you need to know this number. We'll call it S. Heron's formula said area will always be the square root of that semi-perimeter. And then I have three sides, remember? So I'm going to have three things here. 1, 2, 3. And it's very simple. So simple, you're going to think I'm a god. You take that semi-perimeter and you subtract one of the sides. You take that semi-perimeter, you subtract another side. You take that semi-perimeter and you subtract the third side. Isn't that cool? So you got four semi-perimeters in there. It's semi-perimeter times semi-perimeter minus one side, semi-perimeter minus the other side, semi-perimeter minus the third side. And you multiply those together and take the square root. That's the area of any triangle, as long as you know the sides. Let's see if it works for my famous right triangle of a 3, 4, 5 triangle. First thing, find the perimeter. 5, 9, 11, and 12. Find the semi-perimeter, which is half of that, 6. Okay, so the area should be the square root of 6 times 5 minus 6. Oh, why am I erasing now? Times 4 minus 6. Is that going to work? Oh, yeah, it is. Why am I doing 5 minus 6? It's S minus A. 6 minus 5. There you go. 6 minus 4. There you go. 6 minus 3. Okay. Area. How can I mess up something so simple? 6 times, Well, again, 6 minus 5 is a 1. 6 minus 4 is a 2. 6 minus 3 is a 3. Square root of 6 times 2 times 3. 6 times 2 is 12. 12 times 3 is 36. The answer is 6. All right. Well, the old days, how would you have done the formula? You'd have done area is 1/2 base times height. 1/2 times 3 times 4. 1/2 times 12, 6. It works as long as you don't do something dumb like forget to do the s first. 6 minus 5, 6 minus 4, 6 minus 3. All right, that's Heron's formula. And I'm not going to do another problem. Been on here long enough, but it's a good problem. Do it yourself. There's a nice pretty picture. Here's all three sides. Find that area. Ooh. Add up the sides. Let's see. 2, 4, 5, 1 plus 3, 3, 1 plus 2, 4, 2, 7, 2, 4, 2, 7. Here's a problem. I can't do the simple things. 7, 8, 9, 5, 6, 7, 8, 9, 10, 5, 9, 11, 12, 5, 2, 0, 9. Cut that in half. That'll be my semi-perimeter. That'll be a 2, 6, 0, 4.5, I think. 7, 8, 9, 5, 6, 7, 8, 9, 10, 5, 6, 7, 8, 9, 10, 11, 12. 5, yeah, I think so. 2, 6, 0, 4.5. So it's still a calculator problem now because I got to take the area will be square root of 2604.5 times 2604.5 minus, I don't want to do it. All those numbers, you got the idea. Let's see. 2604.5. I got the right. Oh, yeah, I got them. I just didn't want to do the work. It's a calculator problem. And I'm not going to derive it. Just have fun reading it.